In this example, we're going to walk you through the process of importing a 3D model to machine in a two-sided environment. We discuss how to set up the part in the Orientate model form, prepare the file for machining, and ultimately create the toolpaths for both sides. If you've not worked on a two-sided project before, then I recommend that you watch the Introduction to Two-Sided Machining tutorial before continuing with this project. So let's go to File, Close. So let's start by creating a new file. So here we're working with a double-sided job. The width of our part is going to be 6 inches, the height is going to be 10 inches, and the material thickness that we're going to work with is 1 inch. Next up, we need to set our Z0 position for both sides of our material, the left graphic being the top side, the right graphic being the bottom side. I'm going to set it from the material surface where we're going to zero off the same side. There's no right or wrong way to set this, but I prefer to set the Z0 off the same side, where the top side is on the material surface and the bottom is on the machined bed. This way it ensures that the Z is always referenced from the same face of the material. XY datum position, we're going to go in the lower left hand corner, we're going to flip that horizontally, and we're going to work with a very high modelling resolution, and then we could go ahead and press OK. Okay, so we're going to import a model, so we're going to go into the Modelling tab and we're going to use this icon here to import a component or a 3D model. From your project folder, we're going to open up the Marlin FB file. Press open, and because this is a non-native file, the software will automatically open up the Orientate 3D model form, where we can orient, rotate, size and position the model in relation to our setup. So generally you may have to play around with the settings in this form until you're happy with the position of the model. So let's have a look at what we have here. So here we can see that we've got our model. Now if we look at our part down the Z-axis, we can see that it's not really in a practical orientation. So here we'd look at the various orientation options until we found a view that we like the look of. So we could try back, left, bottom, front, right. In this case we'll go with the right option here. But now I need to look at rotating this. So this is my work area. Okay, so we want to just rotate it 90 degrees. So again, you just play around with the settings here until you found the correct orientation, in which case here it's negative 90 in this case. And then the next thing we do is move on to the model size. And so it's important to note here that this grey plane that you can see is not an indication of our job size. This is our zero plane relative to the size of our model. Now the size of our job is actually represented here by this red rectangle. And so it's important not to get those two confused. So we need to look at sizing this model so that it fits within our 6x10 rectangle. So to do that, we come over to the model size section, and I can alter any one of these values, and with lock XYZ ratio checked, the software will automatically scale up or down the model according to the one value that I change, so everything scales in proportion. Now in this case we're going to look at scaling the highest value here, which is going to be the Y axis. So we're going to go over into the Y option here, highlight the value that's currently in there, and we're going to change that to 8. You'll notice the X and the Z have also updated, and then we could go ahead and press apply there. Okay, so for the Z value, I'm just going to round that down just so it's just 0.9. So if we just delete that out and then press apply, you'll see it hasn't changed too much in terms of the X and Y. And I'm actually happy with the height and width of the model that we've got there. And so all we need to do now is just center that in the center of our job space. And we can do that by using this option here to center the model. So now that we have the model in the correct orientation and it's a reasonable size for the material that I plan to cut into, we can move on to the next section in the form where we position the zero plane in the model. Now, as we are creating a two-sided model, we're going to use this option here to create both sides. This will enable us to split the model where we can see here in two, where one side will be positioned on the top of the job and the other side will be positioned on the bottom. And we can alter the model position in relation to the zero plane using this slider here. Okay, so to get a better idea of how this works, let's have a look at this down the x-axis. So this line represents our zero. Everything above it will be on the top side of our material. Everything below it will be on the bottom side of our material. And again, we can adjust that accordingly like so. So in this case, I'm going to put that into the center. If we just put that back in the z-axis, and so looking at our part, we can see that there are areas of the Marlin that are actually greyed out. Now these greyed out areas is an indicator that they're actually below the zero plane, and anything that is a vivid red will be above the zero plane. So in this case, if we just twiddle this around, we can see at the moment, we can see all of the Marlin's head on this side. And if we turn that around over here, we can see that we're actually losing the majority of the Marlin's bill over here. And if we just put that to the side, we can actually see that we're working with quite an interesting asymmetric shape, and that the model itself goes more over to the one side. And so with the current plane position, what we could do is we could look at moving that so we can see the bottom. Okay, so we can see everything here for the bottom side, but if we spin that around, you'll see that now we've just completely lost the majority of the Marlin model on the top side. And so what we're going to do in this case is we're going to set the zero plane position in the dead center of the model, where we have a model thickness of 0.45 above zero and 0.45 below zero, giving us a total z value of 0.9, which is what our thickness is. And so with that in the center, you can see that I am going to lose some areas of the model on both sides, which really isn't an issue here, as we have the ability to override that later on, where we can essentially overcut to get in at these areas. Which brings me to the last option in the form. Okay, so with any model that we import into a two-sided environment, we have the ability to apply an overcut distance, and this is beneficial for two reasons. So let's have a look at our model down the x-axis. So as a standard, the tool can't go any further than the bottom of the model that is being imported on each side, which is at this zero plane that we can see here. And so in our example, we'll be looking at finishing this Marlin using a bullnose tool. So where the point of the tool gets to the bottom of the model on the one side, we may very well be presented with a seam, or what we call cusping, around the edge of the model. And that's down to the fact that we're using a round tool. And the same would apply when we come to cut the bottom side also. And so by applying an overcut distance, typically the radius of the tool, we can cut past the bottom of the model to eliminate the seam or the cusping effect, which would mean that we'd be left with a clean seam, resulting in less manual cleanup time. Secondly, there are parts of the model that we want to cut that won't be visible on each side due to the zero plane and where we've set that as discussed earlier. And so by applying an overcut distance just means that we can get to these areas below the zero plane, and this can be adjusted once we've imported the model to accommodate these kind of areas that we need to get to. So as I said, typically you want to put in the radius of the tool that you plan to use in this section here to eliminate the cusping at the bottom of the model on both sides. And so for a 1/4 inch tool, we're just going to put in an 1/8 value in there. And once you're happy with everything and how the model looks, we can go ahead and press OK. Okay, so let's take a moment to discuss what we are seeing here. So firstly, we are looking at the top side of our model, and if we click on this option here, we'll switch over to the bottom side, where we'll see the bottom side of the model where it's been positioned in relation to the flip direction that we specified at the start of the job. You'll notice that in our component tree we have 3 levels that have automatically been created. We have a model level that contains the actual Marlin model. We've got a level here called tabs that we can add 3D tabs to hold the part in place. And then we have a level here called limit planes, and that contains a component called the limit plane. And this plane is the overcut distance that we specified in the Orient model form before we imported the model into the software. So let's take a look at our part down the x-axis. So the modelling plane is at 0, so we can see our XY0 origin here, and that is our modelling plane, and that is what is at 0, and that's where our toolpaths would have been limited to cut to. But with this additional overcut distance that we specified, which is now in the form of a plane, our toolpaths are now able to go past the modelling plane by 1/8 of an inch to cut to this limit plane, which will eliminate the cusping effect that I spoke about earlier. Now, not only do we eliminate the cusping effect from the tool, but we are also able to get to other areas of the model that are essentially below the modelling plane, like this tail and the fin that you can see there. Now, if we go into the properties of the limit planes component by using this wrench icon here, you'll see that we have a base height of -0.125, so that is that 1/8 inch overcut distance. And we actually have the ability to alter this, which can be very beneficial to getting it into all the areas of the model that we can't quite see. Now, the model that we can see here, whether it's above or below the modelling plane, will get cut, and anything that we can't see won't. And so we know that with that 1/8 inch overcut distance, we'll also be cutting part of this tail, part of this fin here. But what about the area of the tail that I can't see? Well, this is where we can adjust the limit plane to cut further down past the modelling plane to get to the areas of the model that realistically belong on this side. So we can look at altering the base height by using this slider. And then as I move the slider over to the left to create more negative values, you'll see that more of the model is coming in. So at that 0.16, we're now able to see all of the tail there. If I remember correctly, we did have a fin here, so let's just move that slider down. We can see it's starting to actually come through there. Okay, so it's not quite through, so we'll just keep using the slider until we can see all of the actual fin that we need there. Okay, so at 0.3 I can see the whole of the tail, and I can see this extra fin as well. And so with this 0.3 overcut, I know that I'm going to be able to cut everything that is relevant to this side on this side. So let's just close out of the component properties form. So if we switch over to the bottom side, you can use the keyboard shortcuts 1 and 2. Okay, so 2 will take you to the bottom, 1 will take you back to the top. So we'll go back to the bottom side using the 2 key on the keyboard, and you'll see that we have the exact same setup of levels and components. Now, looking at the model, the only thing that we're really missing here is the bill, and we know that the majority of the bill actually leans over to the top side. So here we can also look at altering the limit plane for this side to accommodate for the entire bill there. So let's go into the properties of the limit planes component. So we'll use that wrench icon there, and then we'll just use the slider and slide it along until we have all of the bills showing. Okay, so that's not quite enough there. Keep going. Okay, and then okay, so I think if we just go any further just to check. Okay, so I think at that 0.33 we kind of had it there. Right then, so now that we're happy with what we're going to be cutting on each side, we need to think about adding tabs to hold the part in place. And so to do this, we're going to position the tabs for the top side, and then we're going to simply copy them over to the bottom side. So let's just close out of the properties and we'll switch back over to the top side. So let's make sure that our tabs level is active level, and then any components that we add will be added into the appropriate level. So let's go to our clipart tab. So under 3D tabs, we've got a series of tabs, and we're just going to look at using the underscore circular tab here. And if I double click that, that will bring that into my job, and then what we can do is we can just take it and we can just position it where we need to. Okay, so here I'm just going to put one kind of just horizontally at the bottom of the base here. Okay, it's already set to merge, so it's going to blend in with my model. Okay, so that's okay. I might want to take a copy and move that over to the right hand side. So with that selected, I'm going to press Control, Shift and H on the keyboard, and that will send one over, and then I'll just move that over just so it's connected to the base of the model itself. So at the moment I'm just laying out the tabs. I'm not concerned with the actual heights yet, we'll come to that in a second. I'm going to put another tab up here so I can see we're going to have quite a weak spot up this top end here. So holding down Control, I'm going to select the tab and move it over, and that will create a copy there, and then we'll just rotate it, and then we'll just position that in place like so, and maybe just rotate that again and just nudge that down. Okay, so you can see we are working with quite thick tabs, so let's just take a look at this one in the properties form. Okay, we've got a shape height of 1/4 of an inch. Okay, now as I mentioned earlier, we are going to take these tabs and we're going to copy them over to the other side. And so with a copy on the other side, we'd actually have a total combined tab thickness of 1/2 inch, which I think is way too thick in this instance here. So we're going to look at reducing that down to, let's say, 0.15. And press space just to accept that. So now when I create a copy on the other side, we're going to have a combined total thickness of 0.3, which I think is fairly reasonable. This one will do the same, so just click on that, that will update your properties form, and here we'll type in 0.15, space to enter that in. And then this top one here, I need to be careful here because we don't want to interfere with the actual taper of the actual head of the Marlin. So we're going to look at reducing this quite dramatically in this case. So let's try 0.5 in this case. Okay, so we've got a nice flat tab there, and then if we move that over, you can see that's gone in there. And then when we copy this one over to the other side, we'll have a combined total of 0.1, which is okay. Right then, so let's just close out of the component properties form. And so with those tabs, we're going to look at copying them to the other side. So we're going to take this tab here, hold down Shift, and then select the bottom component there for that tab. So now we can see that they are all highlighted. And then we're going to right click, and we're going to use this option here to copy to the other side. Okay, so that's going to create a copy over onto the other side. So when we switch over, we can see that they've also been added in position here. Now we have a really nice feature in the software that enables us to visualize our part in a multi-sided view. At the moment, we're currently looking at this as if we were looking at two single parts. Here's the top side, and here is the bottom side. Now if we go over to this icon here and click on that, that will put us in a double-sided view. And so here we're getting a real indication of how our model actually looks. So we can see the tabs there, you can see the tab at the top, like so. If we move that over to the right, we can see the tab over there. If we just put that back in the Z view. So to keep my material aligned in X and Y when we flip the material over, I'm going to look at using the non-symmetrical dowel hole method. This is where we would drill dowel holes partially through the top side, and then in the software we'd copy the dowel hole positions of the top side over to the bottom side, where we would then separately drill the holes for the bottom side directly into the spoil board, allowing us to have perfect alignment in X and Y when we flip the material block over. Now, there are many other methods that you could use, but I know that this method is fail-safe as it allows us to use a non-symmetrical hole pattern, because we're going to be able to reverse that pattern and machine it into the spoil board when we flip the part over. And we can ensure that when we flip our material that we only have one possible way that we could relocate it onto our machine surface. And so this eliminates the fact that we might flip the part in the wrong direction to what we've set in the software. And if you want to learn more about the different methods of flipping your material over, then take a look at the Introduction to Two-Sided Machining tutorial, which can be found in the related videos section for this tutorial. So let's go over to the 2D view. We'll just use this option here to zoom active view to the drawing limits. So we're going to use the Draw Circle tool to replicate our dowels. Now the diameter of the dowels that I'm using is 0.33 of an inch. So here I'm just going to go in and I'm just going to randomly position those dowels in place like so. So we're just creating 3 dowels randomly positioned, and then we're going to take each one of those dowels, we're going to right click and we're going to say copy to the other side. So when we turn that over, we can see that they've been copied over for us. So now we're pretty much ready to begin the toolpath creation to cut the Marlin out. So let's switch over to the Toolpaths tab. We're going to tile our windows so we can see the 2D and the 3D view. And then the first and most important thing we need to do is check over our material setup. Okay, so here we're working with a material thickness of 1 inch. XY datum position, we're setting that to the lower left hand corner here. So the Z0 position for the top side, we're doing that off the material surface. Then we move on to the model position in the material. Now we can see our model thickness is displaying as 0.8998, okay? Now this thickness represents the entire model thickness. This is not on a per side basis. So this has factored in the thickness for the top side as well as the bottom side, and it's combined it to create the total thickness here of 0.89. So I'm going to position the model in the dead centre of our material by clicking on this line here. And so putting it in the centre just means that if there are any inconsistencies in the material, we have an even gap above and below to help us avoid any flat spots. So moving on, we've got to check over our rapid Z gaps above our material. So check that your clearance and plunge values are safe and appropriate for your particular example. And then check over your home and start positions. We've got that X at 0, Y at 0, and then your Z gap above the material. So you just want to make sure it's large enough to clear any clamps if you're using them. Now in our case, I'm going to reduce this safe Z gap just to 0.25, assuming that it's safe to do so. So once I'm happy with that setup, I can go ahead and press OK. So the first toolpath we're going to look at creating will be for the dowel holes. So we're going to select the vectors that represent those dowels. We're going to go into the profile toolpath. Okay, so here we're going to have a cut depth of 1/2 inch. We're going to use the select option to open up the tool database. We're going to use a 1/4 inch end mill, press select there. We're going to machine on the inside of those vectors, and we're just going to give that a name. We're just going to call this one dowel holes, and then we could go ahead and press calculate and then preview how this part would look. Okay, so there is the dowel holes there. We'll just put that back and see, then we can preview that like so. Then we can close out, and now we can look at creating some 3D toolpaths. So we're going to start by looking at a 3D roughing toolpath. So that's where we use a larger tool to hog away the majority of our material, and afterwards we'll look at using a finishing toolpath where we'll use a much smaller tool to get in at all the finer detail. So to access the 3D roughing toolpath, we come over to this icon over here. So if we just click in the white space just to deselect those vectors, first thing that we need to do is select a tool from the tool database. In this case, we're going to use a 1/4 inch end mill here. So you want to check over the settings, ensuring that they're safe for your application. Next up, we need to choose how we machine this. So what are we limiting the bounds of our roughing machining toolpath to? So we've got 4 options. We've got the model boundary, that just takes the outline of our model. And so if we was to do that, we'd actually cut the tabs out, so that's no good in this case. We've got the material boundary, so that's using the whole material. Again, our tabs would fall out. We wouldn't actually be holding our Marlin in place, so that's also no good. Selected vector, we don't have a vector. However, we could use the option to use the selected level. Now you'll remember that when we imported our Marlin model, the software automatically created 3 levels for us. Model with the actual Marlin on, limit planes level for our overcut, and a tabs level for our tabs to go into. And so if we was to choose a selected level, it would just take the outline of whatever is in that level. For example, if we chose the model level, the software would use the outline of the Marlin model as the boundary, but because as part of our composite model we have tabs and we have the overcut in here, it will include those as part of its machining boundary, and so we won't cut the tabs out, it's just going to include them as it cuts around the edge of the actual model itself. So we're going to look at using the model level as our boundary for machining. So if we use the model level there, so now we could put a boundary offset in. So this is just so that the centre of our tool can roll past the edge of our part by an offset that we specify in here. That just means that it cuts around the edge of our model. So here I'm just going to go with the full diameter of the tool I'm using, so 1/4 inch in there. Then we can specify a machine allowance, so I'll put in a small 0.03 just so that we have a skin of material left on the finished surface for the finishing tool to actually cut at. So the roughing strategy, we're going to go in a Z-level strategy along the X-axis, and then we could go and give that a name. We're just going to call this one 3D roughing, and then we could simply go ahead and press calculate. Okay, and so that's what our part would look like, and then we could go ahead and preview that toolpath. And so here we're able to see all of the Z-level steps that tool has hogged away at the material using that large end mill. Now if I run my cursor over the deepest area, so it's pretty much the outline of our Marlin, you'll see at the bottom displayed in our interface we're showing a cut depth of -3/4 of an inch. Okay, now we know our material thickness is 1 inch, and so our modelling plane is going to be at the dead centre, which is 1/2 inch, which is where we set the model in the dead centre of our block of material. And so we can see that the software has actually accommodated the limit plane in this roughing toolpath, where it's cut a further 1/4 of an inch to take us to the 3/4 that we're seeing at the bottom there. Now we know that we set the limit plane to roughly around 0.3, so we know that when we come to run the finishing toolpath we should have a total cut depth of around 0.8. And so I just wanted to highlight this toolpath has accounted for this limit plane. It's also accounted for the tabs also, and in terms of the actual plane itself, you need to be very wary, and it's important to be aware of the total cut depth, ensuring that your tooling can actually reach into these deep areas. So let's just put that back in Z, and then we'll close out of the Preview Toolpaths form. So now we're going to look at running the 3D finishing toolpath. So in here we're going to select a tool. So here we're going to use an 1/8 inch ball nose here, so a much smaller tool. We're going to use the selected level where the model level will be our machining limit boundary. I'm going to put an offset in here that is the same diameter as the tool that I'm using. We're going to machine this in an offset strategy. We're just going to call this one 3D Finish, and we'll go ahead and press Calculate. The software will take a moment to calculate that for us, and then we could go ahead and preview that toolpath. So here we can see that the software is taking that smaller tool and it's able to get into all of the finer details here. So if we just maximise the 3D view, we're just going to switch off the double-sided view. And so this time, if I run my cursor along the edge here, you can see that I'm displayed a value of -0.8. And so again, it's just showing you that our toolpath is actually reaching down to the limit plane that we've set there in order for us to cut everything that we wanted to on this side. And so that is everything for the top side. So in reality, we would actually take our block of material off of the machine bed at this point. We could look at inserting the dowels into these holes, and then now we'd look at creating the toolpaths for the bottom side. So let's switch over to the bottom side and we'll close out of the Preview Toolpaths form. So let's just go ahead and tile our windows. So the first operation that we're going to do here is looking at machining the dowel holes of the bottom side directly into the spoil board. And so before we do that, it's always good practice just to double check over your material setup. Okay, so the thickness is the same, XY is the same. The Z0, this time we're actually referencing that from the machine bed. You'll remember right at the start of this tutorial, I set it up so that we're always referencing from the same face. And so for the bottom side, we're actually going to set the Z0 off our machine bed. Model position and material, we do not want to touch this. This just stays as it is, exactly the same as what we did on the top side. We do not want that model to move within our material. Rapid Z gaps and home and start positions are all safe and appropriate, so now we could go ahead and press OK. And so with the material block out of the way, the first operation here is to profile the dowel holes that we've got on the bottom side straight in to the spoil board. So we're going to take those vectors and then we're going to go over into the profile toolpath here. So for the start depth, we're actually going to put in 1 inch there, okay? So that's going to be the same as our material thickness. As we've set Z0 from the machine bed, we need to factor in the material thickness so we can essentially start at 0. Then we're going to have a cut depth of 1/2 inch. We're going to select a tool from the tool database. In this case, we're going with a 1/4 inch end mill, so we'll select that. We're going to machine on the inside of those vectors, and we're going to give this a name. So we're going to call this one dowel holes. And just for good measure, I'm just going to put in a kind of disclaimer here just to remind me that this is in the spoil board only. And then we could go ahead and press calculate. Okay, so the software's just telling me that we're going to cut through into the spoil board. That's fine, that's what I intend to do. So when we look at that, we can see it'll come down. When it gets to the machine bed, it's going to cut the 1/2 inch thickness there for our dowel holes, and then we could go ahead and preview that. This preview doesn't actually determine anything because this is essentially our block of material that we'll be machining our Marlin model into, but we can get an idea of where the positions will be, and if we switch on the visibility of the toolpath, we can see actually the direction where the toolpath is actually going to go. But remember, this toolpath is in the spoil board only. And so with the dowel holes cut into the spoil board, we can now take our material block that has half of the marlin cut on the one side, and we can basically line up the dowel positions and then secure the part in place, and then we know then that we have exact alignment in X and Y for both the bottom side along with the top side, and I can begin running the 3D toolpaths for the bottom side. So let's just reset this preview. We'll just switch off the visibility of that toolpath. We'll close out, and now we can think about machining the roughing for the bottom side. So we're going to go into the 3D roughing toolpath. So let's select the tool from the tool database. So again, we're going to use the 1/4 inch end mill. We're going to use the level, the model level, we'll go the same offset, same machining allowance. We're going to do this in a Z-level strategy along the X-axis, and we'll just call this one 3D roughing. Then we could go ahead and calculate that. And then we could preview what that part looks like. And so if we switch on the multi-sided view, you'll see that with that toolpath, we're cutting through our part. We've still got our part securely held in place using those tabs. If we just turn that around, we can see how that looks. Okay, so that's the 3D roughing for the bottom side. So let's close out. Now we'll go into the 3D finish toolpath, select a tool. We're going to use that 1/8 inch ball nose. We're going to use the model level for our boundary. We're going to go with the same 1/8 inch boundary offset. We're going to do this in offset strategy, and we're going to call this one 3D finish, and then we could go ahead and press calculate. Okay, and then we can preview that toolpath, and then we should see that cut all the way through once the preview's been done. Okay, so there is our finished marlin. So you can see our tabs are holding that marlin in place. A top tip here is if you hold down Control, you'll see at the bottom here I'm actually displayed a thickness, okay, and you'll see there we've got a tab thickness of 0.3, okay, so that's because we set each one of those tabs to a thickness of 0.15 on each side. And up here, if we have a look, we've got a thickness of 0.1 over there. Okay, so our part's going to be held securely to our material block. So let's close out of the preview toolpaths form. So now that we've ran all the toolpaths that we need, we can now go ahead and save the toolpaths out. So switching over to the top side, we're going to go into the Save Toolpath option. So we know that we're using the same tool for the dowel holes and the 3D roughing, so we can select both of those and we can look at outputting those to one file. We've also got this option here to add side to the toolpath name. So if we check that option there, that will enable us to save the toolpath out, where it's just going to add the side to the toolpath name so we know whether that's the top or the bottom. Select the appropriate post processor from the list and then use the Save Toolpath option, and you'll see it's named that with top at the beginning along with the first toolpath that's in the list. Okay, and this is applying to both of these toolpaths, so you could change the name of that if you wanted to. And so here we could go in there, we could say top dowel holes and 3D roughing. And then we could go ahead and save it, and then we could just uncheck these and then check the 3D finish, save toolpath, top 3D finish, save that out there, close out, and we can switch over to the bottom side. Okay, so for the bottom side, let's save this one out. So this time we're just going to save this one out separately because we are only cutting into the spoil board with this toolpath. So we're going to uncheck that option there, but we're going to add the side to the toolpath name, press Save Toolpath, and you'll see that it's added the word bottom in front so we know which side that this toolpath belongs to. So we can go and press save into the 3D roughing, save that out, bottom 3D roughing, press save, and then finish, and you'll see it's got bottom 3D finish, and you can see all of the other toolpaths here. and then we'd simply take those over to our CNC machine to run them and cut the marlin out. Okay, so let's go ahead and save the files. So go to File, Save As, and then in the Project folder, we're going to call this one Two-Sided Marlin, Two-Sided Machining. Press Save, and you can access that from there.